Welcome to my YouTube channel. Our today topic is, what is miniature circuit breaker? MCB advantages and disadvantages. Miniature circuit breaker MCB. A miniature circuit breaker MCB is an electrical switching device designed to protect electrical circuits from excessive current and overloads. It is commonly used in residential, commercial, and industrial applications to ensure the safety and proper functioning of electrical systems. Here are the key details about miniature circuit breakers. 1. Function. The primary function of an MCB is to detect and interrupt the flow of electrical current in the event of an overload or short circuit. It acts as a switch that automatically opens or trips to disconnect the circuit when it detects abnormal current conditions. 2. Construction. An MCB consists of a switch mechanism and a thermal magnetic trip unit. The switch mechanism controls the circuit on or off operation, while the trip unit sends the current and trips the breaker when necessary. 3. Trip units. MCB are available with different types of trip units. A. Thermal trip unit. It responds to prolonged overcurrent conditions caused by excessive load or a minor short circuit. It uses a bimetallic strip that bends due to the heat generated by the current flow, eventually causing the breaker to trip. B. Magnetic trip unit. It responds to short duration, high current surges that may occur during a severe short circuit. It uses an electromagnetic coil that creates a magnetic field when the current exceeds a specific threshold, tripping the breaker. C. Thermal magnetic trip unit. This type of trip unit combines both thermal and magnetic elements to provide protection against both overloads and short circuits. It offers a more comprehensive and versatile protection mechanism. 4. Current ratings. MCB are available in various current ratings, typically ranging from a few amperes to a few hundred amperes. The appropriate current rating should be selected based on the specific electrical load requirements of the circuit. 5. Breaking capacity. The breaking capacity of an MCB indicates the maximum current it can safely interrupt without causing damage or compromising its functionality. It is important to select an MCB with a breaking capacity suitable for the expected fault current levels in the electrical system. 6. Tripping characteristics. MCB are available with different tripping characteristics such as B, C, and D. These characteristics define the response time of the breaker under different overload conditions. Each characteristic is suitable for specific types of loads, such as resistive, inductive, or motor loads. 7. Installation. MCB are typically DIN rail-mounted devices that can be easily installed in electrical distribution panels or consumer units. They are designed to be compact and modular, allowing for easy replacement or addition of breakers as needed. 8. Resetting. After tripping, an MCB can be manually reset by moving the switch to the off position and then to the on position. This resets the internal mechanism, allowing the breaker to resume normal operation. Advantages of miniature circuit breakers MCB. 1. Overcurrent protection. MCB offer reliable protection against overcurrents and short circuits. They can quickly detect abnormal current conditions and interrupt the circuit, preventing damage to electrical equipment and minimizing the risk of fire. 2. Quick response time. MCB have a fast response time when compared to traditional fuses. They can trip within milliseconds upon detecting an overload or short circuit, minimizing the duration of the fault and reducing potential damage. 3. Selective tripping. MCB can be selectively coordinated with other protective devices in an electrical system. This means that when a fault occurs, only the MCB closest to the fault will trip, allowing the rest of the system to remain operational. This enhances system reliability and minimizes downtime. 4. Resettable. Unlike fuses, MCB are resettable. After tripping, they can be easily reset by switching them off and on. Again, this convenience eliminates the need for replacing fuses every time a fault occurs, resulting in cost savings and reduced maintenance efforts. 5. Cost. Compared to traditional fuses, MCB can be more expensive. The initial investment cost of installing MUX in an electrical system may be higher, especially when multiple breakers are required. However, this cost is often offset by the benefits they provide, such as resetability and improved protection. Disadvantages of miniature circuit breakers MCB. 1. Limited braking capacity. MCB have a limited braking capacity compared to other types of circuit breakers, such as molded case circuit breakers MCB. This means that they may not be suitable for applications with very high fault currents, requiring the use of more robust protective devices. 2. Sensitivity to ambient temperature. The thermal trip unit of an MCB can be influenced by ambient temperature. In high-temperature environments, it may result in a reduced tripping capacity, potentially compromising the overall protection of the electrical system. 3. Limited fault detection capabilities. MCB primarily provide protection against overcurrents and short circuits. They may not offer advanced fault detection features like ground fault protection or arc fault detection, which are available in some specialized circuit breakers. 4. Limited discrimination. While MCB can be selectively coordinated, achieving perfect coordination across all fault levels can be challenging in situations where multiple faults occur simultaneously. Coordination may not be achievable, leading to nuisance tripping or inadequate protection. 5. Cost. Compared to traditional fuses, MCB can be more expensive. The initial investment cost of installing MCB in an electrical system may be higher, especially when multiple breakers are required. However, this cost is often offset by the benefits they provide, such as resetability and improved protection. It's important to note that despite these disadvantages, MCB are widely used and considered a standard protective device in many electrical installations due to their overall effectiveness, reliability, and ease of use.